Welcome back, dear students. Today we're going to discuss chapter 3 of Relational DBMS, and it is part 3. We're going to discuss about normalization and its types, atomic, multivalued and composite attributes, redundancy of data, 1NF, partial dependency, and 2NF. So let's begin. First, we need to know what are the different types of normalization. In the last class, we discussed about what normalization is, where we said that it is a process of removing redundant data and distributing data amongst smaller tables, putting some relationships among them so that we can reconstruct the actual data by joining them, by simply doing some natural join kind of thing. Now here, first we will discuss about the types of normalization. 1NF, 2NF, 3NF, BCNF, 4NF and 5NF. These are the basic different types of normal forms. Apart from this, there are two more kinds like the DKNF and TJNF, right? Domain key normal form and template join normal forms are also there in the normalization classification. But here we need to understand the concept of this normalization, starting with 1NF. It is basically says the data should not be redundant and table should contain atomic attributes. 2NF says that the non-key attributes must be fully functionally dependent on the key attribute, that is primary key or candidate key. 3NF says there will be no transitive dependency exist in the table. So in the discussion of the first three, starting with the first one, that atomic attribute should be there in every table. For the second normal form to achieve, it must be in 1NF, then there will have full functional dependency, then we call it a 2NF. And 3NF, when it is in 2NF and also there is no transitive dependency exist, then it is 3NF. Then comes the turn for BCNF. BCNF is stricter than 3NF, so in a separate class when we'll be discussing about 3NF and BCNF, there we will tell you about the story why BCNF is stricter than 3NF and what is the basic difference between them. BCNF is called as Boyce Codd normal form. Then comes 4NF. So before we discuss about 4NF, we say that it is in BCNF, and then there should not be any multi-valued dependency, right? So this is the thing for 4NF. And 5NF also called as project join normal form, PJNF, right? So this is what about the 5NF, right? Now the question is that what was BCNF? BCNF is something where non-key attribute cannot be a determinant. So NK means non-key attribute. What is a non-key attribute? First to tell that. Let's say in a relation R, there are few attributes A, then B, C, D. Now in this relation, if we have AB as the candidate key, so C and D are called as non-key attribute. So if it is so that non-key attribute becomes a determinant of a partial key, then it is called a trivial dependence. BCNF says or ensures that non-key attribute cannot be a determinant of a partial. So let's move on to the discussion of each and every normal forms one by one. So in this particular discussion, this is the overview of all different types of normal forms that we can discuss. Now before we discuss about the first normal form, we should have some prerequisite knowledge. About what? About different attributes. Now let's first discuss about the three different types of attributes. One by one, if we say, first is atomic attribute, then we'll talk about the multi-valued attribute, and then the composite attribute. And we will exemplify each one of them. Though in the year modeling chapter, we come to know about different types of attributes, but here in the physical schema diagram, we will understand or delve into the matter how these attributes are used in a relational database. Okay, so here in the relation, I mentioned three different columns. One is ID, department ID, then name and the address. So the department ID, we can see that is a single and simple value. It has an integer 20, and in the name field it contains three names, Susi, Rusi and Tusi. So it contains multiple values. So one attribute which is containing multiple value is called as multi-valued attribute. Then comes the address. An address is a composition of many reducible parts or subparts. 100 by A2, this is the apartment number, then it is a K apartment, then the road is BT road, the city is Kolkata, and this is the pin code. So there are 1, 2, 3, 4, 5 different reducible atomic parts of this attribute called address. So address can be further decomposed into few meaningful atomic values, right? So here, if they are divided into meaningful atomic values, then it is called as a composite attribute, right? So in this example, address is a composite attribute. Here name is a multi-valued attribute, because in department ID 20 there are three different names whose address are same. Okay, so this is the example of atomic, multi-valued and composite attributes. So this is the different types of attributes that we discussed about. Okay, starting with the atomic, then multi-valued, then composite. Now we'll have the concept of redundancy of data. Very clearly or vividly I mentioned here, there is something called repetition and another thing is called unnecessary. Okay, these two terms are key, means very important. If we talk about the data redundancy, it is a condition created within a database or data storage, and it is a technology in which the same piece of data is held in two separate places. Not only two, it can be in multiple places. So this can mean two different fields within a single database or two different spots in multiple software environments or platforms. So basically, the redundancy, to understand what exactly redundancy is, the term unnecessary and repetition both should coexist. Because if it is a repeated data, it is not redundant always. Because there are sometimes called useful redundancy. So useful repetition or needful repetition. So that is not called redundant. Means unnecessary repetition, then only it is called redundant. Okay. Now here is an example of redundant data. Like this table partitioned into 4 chunks called sub-resources, and each chunk or sub-resource is assigned to a server group. Okay, so this is server group, and the same information may be in different places, right? And it is site 1, it is saved, in site 2 also it is saved, but if you see here, this SP is here, and also here this ST are here, and it is also here, and similarly this too. So what I want to say here is that in the database there could be a repetition of the same value again and again and unnecessarily. So that is called the redundant data, or it can be said as redundancy of information. Now let's talk about the first normal form. Basically, the first normal form, a relation will be in 1NF if it is containing an atomic value. It states that an attribute of a table cannot hold multiple values. It must hold only single valued attribute, and the first normal form disallows the multi-valued attribute, composite attribute, and their combination as well. So these are the things that we need to be careful about. And let's say a relation employee is not in 1NF because of multi-valued attribute, that is EMP phone. So if we have 4 attributes of a table called EMP table, suppose there are 4 attributes or columns. One is employee ID, that is unique for different row or tuple. Then employee name, that is also unique to some extent, but sometimes it can be duplicate. The employee phone number, and if the phone number field is containing more than one value, that means it is multi-valued, then it is not in 1NF. And employee state, that can be repeated or it can be different, so it doesn't matter, but the phone number field is having more than one value, so in that case it is violating the 1NF because it doesn't allow the multi-valued attribute or composite attribute. So in detail, if we want to say about first normal form, there are 3 key points associated with this first normal form. That is, the data in each column should be atomic, no multiple values separated by comma. So here in the first example, if we say the department name is IT and there are employees like Sam, Mike and Sean, so in the single column there are more than one attribute value, so it is a multi-valued case. So it is not possible to select, insert or update and delete just one employee, because in the same employee column there are 3 names. Now what would happen if we have divided the employee into 3 different columns? Like 3 names are there at max, so we can put them in 3 different columns like employee 1, employee 2 and employee 3, right? So in this case there could be a different problem, that is the table does not contain any repeating column group. But in this example here, you see the employee 1, employee 2, employee 3, if we had the table in this format, then it is a repeating column group, and that is not allowed in 1NF. Okay, so look at the point number 2. So as per that, it is not acceptable. So more than 3 employees, the table structure change is required. So if in the same column more than 3 employee names are there, then we have to restructure this table because it is not possible to accommodate the 4th value. Similarly, less than 3 employees, so wasting of disk space. So let's say we have created some column but which are not being utilized, so that is also not correct, or wastage of this space, right? Now the third one is identity each record uniquely using primary key. So if department ID is the primary key, then it can uniquely identify every department. Like department ID 1 is basically determining the department name called IT. Department ID 2 is determining HR department. Then there could be a foreign key kind of thing where we have the department ID. Along with that, we have the employee as well. So in department 1, there's 3. Department 1, there are few employees who are in the same department, that is Sam, Mike and Sean. Okay. So this is how the first normal form looks like. That means there should be atomic values for every column. There should be no repeated value or repeating column group exist. Okay. So every column or attribute must be atomic. That means irreducible. Then only we can say that it is in first normal form. Now coming to very easy concept, that is, this is the prerequisite knowledge for understanding of second normal form. So the prerequisite knowledge of second normal form is the concept of partial dependency. Basically, there should not have any partial dependency in 2NF, because 2NF supports only full functional dependency. Now we need to understand what partial dependency is all about. Okay, let's say in a relation there are 4 columns A, B and C, D, where A, B is the key attribute which is determining non-key attribute, that is C, D, and also a part of the key attribute is B, which is in turn determining C, which is a non-key attribute. Now what would happen in this case? In this case, B determines C. This is basically a partial dependency, because AB was the whole key and B is the part. C, D are the non-key attribute. So one of the non-key attributes is partially dependent on B, right? So that is why it is called a partial dependency. AB is the whole primary key that determines C, D, which are nothing but non-key attributes, and also B alone can determine C. Now we'll discuss about the 2NF. A relation will be in 2NF if it is in 1NF and all the non-key attributes are fully functionally dependent on the primary key or candidate key. If I give an example here, ABC is the key attribute and D, E, F, G, H all are non-key attributes. Fine. Now what about this B? We know ABC is the whole key, whereas B is the part of the key, and F is non-key, which is functionally dependent on only B. So B determines F. That means F is dependent on B and B is nothing but a partial key. So here in this particular example, we can understand that here this partial dependency exists, and if there exists any partial dependency, then we say that it is violating 2NF. So it is not in 2NF because it is violating full functional dependency. Rather, you can see here from that there is a partial dependency. So if there is any partial dependency exists in a database table, then we say that it is incompatible with 2NF. So this particular relationship is also 2NF incompatible. So if it is 2NF incompatible, then we need to decompose it into 2NF, right? So how to decompose it into 2NF? Like, we can divide it into two tables where ABC will determine DEGH. So DEG and H. This is one table, and another table where we will have B determines F, right? So as simple as this. So here it is ABC, and the rest part is DFGH because F will not be included here. DEGH is the right part. So B determines F will be the next table. So this entire relation R, let's say R is the table, which is decomposed into R1 and R2, let's say. So these are the two sub-relations where B determines F is one relation, and another relationship is there, that is ABC determines DEGH. Okay, so this is the discussion about 2NF. Now let's move on. So what 1NF and 2NF? So if we summarize these two, uh, in normal form 1, that means in 1NF, what we must have, that is atomic attribute. Let's say ID is equal to 20, that value is atomic. It is indivisible or irreducible. And it must not have multi-valued and composite attribute, like in a single name field there are multiple names, or in the composite attribute is there, like it can be decomposed into several meaningful subparts. So that is not allowed in 1NF, and it should not contain redundant information. So that thing also be kept in mind. And multiple column value, that is like the employee name is divided into three different repeating column values. So employee 1, employee 2, employee 3, that is not also a good practice. So we should eliminate those things. That means we must not have that in 1NF. And what we should have, that is atomic attribute. Okay. Now what we must have in 2NF? 2NF says that we must have full functional dependency. What it means? It means all the non-key attributes must be fully functionally dependent on the key attribute or primary key. That means, let's say in the previous example, here ABC determines DEFGH all if it is so. Then we could say that this is a 2NF compatible because all DEFGH, all non-key attributes are fully functionally dependent on ABC. If it is like that, then we could say that this is 2NF compatible. But here in this example, it is not 2NF compatible because there is a partial dependency exists between B, the part of the key that determines F. So this is why it is 2NF incompatible. Okay. So it must have full functional dependency, that is true, and it must not have partial dependency. So these two things are quite opposite: full functional dependency and partial dependency. So must not have, it must not have partial dependency, and must have, it must have full functional dependency. That's it. So this is all about today's class. Thank you so much. Keep watching our DBMS online classes and see you in the next class.